last class we did basic definition of work and units of work, formula of work, and different cases like at different angles. What is the value of work? So based on that, let's see a few questions. So first question for you: for work done to be maximum, angle between force and displacement should be. For maximum work, what is the angle between force and displacement? Or for what angle between force and displacement work?
0.
0 degree.
When the angle is 0, cos theta is also 1. Work formula is F into S into cos theta. So when theta is 0 degree, cos theta is 1, and cos theta 1 is maximum value of cos theta. So this maximum can be 1 cos theta. It can't be more than 1. Like that also I told you in last class. Cos value is maximum 1. So maximum value of work is F into S. When a body moves in a circular path in a horizontal plane, work done is. When a body moves in a circular path,
0.
can you explain why?
Because the displacement will be 0, so there's no work done.
Okay, I'm interested in more answers. When a body is moving in a circular path in a horizontal plane, work done is 0. Answer is correct. There is no doubt about that. 0 is correct, but I'm interested in more explanation. What Khushi said here is when it's moving in a circular path, displacement is 0, so work done is 0. But did this question ever say that the starting and the ending point is same? See, body is moving in a circular path means it can start from A and it might be at B during the journey. So A to B also work done is 0 or not? You got my point, Kushi. So when I say it's moving in a circular path, I'm not saying that it has completed a circular path. It is just moving in a circular path. You got the difference?
Yes, sir.
In my notebook, I've written it as in a circular motion at an instance, angle
Hmm?
between the centripetal force and the displacement at the moment is 90 degrees.
Hmm?
Hence, work done is 0.
Okay, so that is what I actually made you write that day. So see what happened is,
Oh, yeah.
see if you remember, or like see what happens in a circular motion. Suppose a body is moving in a circular path. Now at any point, like if a body is moving in a circular motion, it experiences an inward, like there's an inward force acting on it called as centripetal force. That's the real force acting on it. So centripetal force is acting inwards, okay, at A. Same, if I the same body is at B, what is the direction of centripetal force? Inwards, like this, okay. So at different point the direction of force changes and it is always inward towards the center of the circle, okay. Even here, what is the direction of centripetal force? Inward towards the axis of rotation or the center of the circle. But then see at any instance, like at this instance A for example, the body is actually moving in this tangential direction, okay, like downwards, just a little bit. It's not this much, like I've just made the arrow longer to show you the direction is downwards. For example, at this moment, what is the direction of displacement? It's going in this direction, okay, a little bit in that direction. Same here, what is the direction of displacement? It's going in this direction, okay. So when a body is moving in a circular path, the displacement is always changing, the direction of displacement is always changing, and the direction of force is also always changing. But at any instance, for example at A, angle between force and the displacement is 90 degree. Same at B, between displacement and force is 90 degree. So at any point the angle between force and displacement is 90 degree, and since the displacement and force is 90 degree with each other at any point, there is no work done by the centripetal force in a circular motion. Is that clear?
Yes, sir.
So can I say the
Yeah,
direction of force applied is not equal to the displacement of the object, and they have 90 degrees distance between them,
not
something like
distance, angle between them.
angle between, yeah.
So instead of telling that it is not equal, like that is just an extra line you are adding, you can directly say displacement and force is 90 degree to each other.
Okay.
Okay, just re-explain the point. See, what I am trying to say is, if a body is moving along a circular path from anywhere to anywhere along the circular path, let's say from A to B, it did not complete a circle. Okay,
So
so
is it zero or no?
uh-huh,
Is it zero or no?
displacement is not zero, yeah, but the
Work done.
work done is zero.
Yeah. Okay.
Work done is zero, yeah. Object is moving along the circular path and it has just traveled from A to B. It's just going from A to B till now. In this journey, is work done zero? I said yes, work done is even zero in this journey A to B, or even A to C, it is zero. But then what is explanation for that? I said, see, between A and B, there are infinite points. Okay? There's not one point, there are infinite points. But if you take any point between A and B and try to understand the force and at that moment, okay, like at A, for example, starting point only, if I try to understand the direction of force, okay, force is acting like inwards towards the center, while at A, displacement is in this direction. So it is 90 degree. So at the instance A, work done is zero. Similarly, if I divide this journey from A to B into infinite small segments, okay, at any segment work done is zero because in all those small segment, the direction, the displacement, and the force is perpendicular. So at any instance, the force is perpendicular. Force is also changing, displacement is also changing. But at any instance, they are perpendicular, means they are 90 degree with each other. So there is no work done at any instance. So even if we fragment this whole journey into small parts, in every single part work done is zero because for all those small, like infinitely small part, displacement and force is perpendicular to each other. That's the point I'm trying to make. Okay, let's go to the next question. What is SI unit for work?
Joule.
Joule. Okay, we studied this last class. Work done formula is force into displacement. Force unit is Newton and displacement unit is meter. Therefore, product is Newton meter, which is also called as joule or joules. 1 joule is equivalent to how many erg?
Uh,
Okay, that
10 to the power 7.
10 to the power 7.
10, 10 to the power 7 erg,
Yes.
correct?
Yes.
Yes.
So see the arrow mark I have put here, no, that is basically because I am not able to write 10 to the power 7. So that means 10 to the power 7. A joule is 10 to the power 7 erg. I did the derivation in the last class. So please remember this is 10 to the power 7 erg. Like how do we do this is uh, basic, basically work is force multiplied with displacement. Unit for force is Newton and in unit for displacement is meter. So work becomes Newton meter, which is also 1 joule. But then 1 Newton is 10 to the power 5 dyne and 1 meter is 10 to the power, okay, it's 10 to the power 2 centimeter. So this becomes 10 to the power 7 dyne centimeter. 1 dyne centimeter is 1 erg. So this derivation is also asked in exam. So please try to remember this. 1 joule is equivalent to 10 to the power 7 erg. Clear? Okay, let's move ahead. Next question. A block of mass 20 kg is pulled up a slope as shown in the figure given below with a constant speed by applying a force of 200 Newton parallel to the slope from the initial position A to the final position B. Work done in moving block from A to B is how much work is done in moving the block from A to B? That's the forces in this direction along the slope and it's going along the slope. So what is the angle between force and displacement in this case? The body is moved upwards like along the incline and the force is like it is applied along the incline and it's moving also along the incline. So what is the direction between force and displacement here?
600 joules.
That is your final answer. So see 600 joule is actually correct here. See, I told you when the force and the displacement is in the same direction, then work done is force into displacement. In this situation, isn't force and displacement same direction? Look closely. 200 Newton, what's the direction? Like this. And how this body will move? Body will also move in the same direction, along the same incline. So here force and displacement has no angle between them or zero angle between them. So therefore formula is Fs only. So 200 into 3, 600 joules. Suppose they have
Yes, sir.
given the force is acting like this 200 Newton and the displacement is like this. Okay. So force this direction. So you can write force here, displacement here, and then measure the angle between them. Then angle would be required. We need to, in that case, we'll have to find the angle. Okay, theta, we need to find or angle should be given. Okay, next concept, work done by gravity. So if suppose we have an object which is moving towards Earth, let's assume this ball is moving towards Earth. Why is it moving towards Earth? Because Earth is applying a gravitational pull on the object. Earth is attracting the object. So Earth is doing some work on the object. So again here work done is equal to force multiplied with displacement. Can I say that? Okay, but then can you first tell me how much force Earth is applying on the object if mass of the object is m? Force which Earth apply on the object is equal to weight of the object. So what is weight? Weight is nothing but force which the Earth applies on the object. And what is formula for weight? See, formula for weight is mass times gravity mg. So here we can say that work done is nothing but mass into force. Like force is nothing but mass into gravity. So if any object is moving towards Earth, Earth applies weight on the object, and that weight is product of mass and gravity. Okay. Now this object is traveling through this height. Suppose initially it was at height h. Okay, initially it was at height h, and it comes to the surface of Earth. So how much it traveled? The displacement here is nothing but it's equal to height of the object. So when object travels from height h to the ground having mass m, work done is given by formula mgh. So this is the work done by Earth in pulling the object from that height to this height, from that height h to the ground level. So see, when the object is moving in the opposite direction, like if it's going from ground level to that height, some height, okay, this time it's going in the opposite direction, it's going up like this. In this case also, weight is acting downward, mg, but the displacement is opposite direction, h. So here the formula is mg h with a minus sign. See, for the new students who were not present in the last class, I'll tell you why we have a minus sign here. Actually, we learned in the previous class that when force is opposite to displacement, then angle between them is 180 degree. And also one thing which you should remember is cos of 180 degree is minus 1. So these two things we discussed in the previous class. When object is going opposite to the displacement, sorry, the force is acting opposite to the displacement. Okay, angle becomes 180. So this becomes minus 1, and like cos 180 becomes minus 1, and therefore just the sign changes. From mgh it becomes minus mgh. Power or rate of doing work. Power is defined as the rate of doing work or the rate of transfer of energy. So formula for power is work done divided by time. Okay. So power is nothing but work done upon time. Power is a scalar quantity, means it like work, it does not have a direction. SI unit for power is watt, which is joules per second. Since it's the ratio of work and time, work unit is joule, time unit SI unit is second. So the ratio is joules per second. Okay. Joules per second is also called as watt. So watt hour, watt. And the CGS unit is erg per second. Other units of power which you will be using is kilowatt. This you'll see very often. So 1 kilowatt is just like a kilogram is 1,000 gram. 1 kilowatt is 1,000 watt. A bigger unit of power is megawatt. So 1 megawatt is nothing but 10 to the power 6 watt. Okay, kilowatt is 10 to the power 3 watt and megawatt is 10 to the power 6 watt. 1 horsepower is 746 watt, 0.746 kilowatt. So please remember that, that's really important. Now we just need to do a lot of numericals. Can we get started? A boy of mass 40 kilogram climbs up the stairs and reaches the roof at a height of 8 meter in 5 seconds. Find the force of gravity acting on the boy. A boy of mass 40 kg climbs up the stairs and reaches the roof at a height of 8 meters in 5 seconds. So it reaches 8 meters in 5 seconds. What is force of gravity acting on the boy? Force of gravity is nothing but weight of the boy. Okay, please don't get confused. Force of gravity means nothing but the weight of the boy.
We use W is equal to mgh.
That is for the second part. First part, they are only asking for the force. So force is weight, which is mg. Okay, so here I can say the force against gravity, first part, is mg. So 40 kilogram multiplied with g, 10 meter per second square. So that is 400 kilogram meter per second square, or 400 Newton. Okay, unit for force is Newton. Kilogram meter per second square is nothing but Newton. Second, okay, second part, work done by him against gravity. So here we can use force multiplied with displacement, or mgh. Mg we just calculated, that is 400, right? So directly you can multiply with h. So it is 400 into 8 meters. So that is 3200 Newton meter, or 3200 joules. Okay, so then the third part, power is work done upon time. So this is 3200 divided by time, 5 seconds. Okay, so 3200 divided by 5. 5 goes
640.
640.
640 joule.
640.
Yeah, 640 joules, watt, joules per second, which is 640 watt. Am I clear? Is this simple? So in the same question, we learned how to find force, how to find work, and then how to find power. Okay, so we can move on to the next question. A man spends 7.4 kilojoule energy in displacing a body by 74 meter in the direction in which he applies force in 2.5 seconds. Calculate the force applied and the power spent in horsepower by the man. See here, I like to just clarify you one thing. Though we are going to study about energy in this next part, energy spent and the work done are the same thing. Like for example, as a person, if I'm spending 1000 joule of energy, I'm basically doing 1000 joule of work. So how much ever energy you spend, that is the amount of work you do.
So first I have to write down all the things given to us.
Mhm,
Work done is 7.4 kilojoules.
mhm.
S is equal to 74 m,
So
and T is
7
equal
point.
to 2.5.
Okay, okay,
S is equal to 74 m,
mhm,
and T is equal to 2.5 s.
okay.
Then first we have to find the work done. W is equal to F into S. Force is equal to work done upon distance. So
So
force will be equal to
okay, so
7.4 into 10 to the power 3 upon 74. And then
first, using the formula work is equals to force into displacement, we write force is work done by displacement by manipulating that formula. So what is work done?
7.4 into 10 to the power 3 by 74.
So just write multiply with 1000, because 7.4 kilojoule is 1000 joule. So multiply with 1000 to convert this to joule. Displacement is 74 meters. Okay. Now we need to multiply this. Okay. So we move this decimal here. Okay. Now this is 7400 divided by 74. So 100 Newton. So that is first part. Second part of the question is like they're asking us to find power. So power is nothing but, okay, power also they're asking in horsepower. Not a problem. Just find in water. Like it's 7400 joules. Okay. Power formula is work done by time. Work done is 7,400 joules in the SI unit, divided by time 2.5 seconds. Okay, do the calculation. 7,400 divided by 2.5 is how much? If this many watt.
So is it 2.96 kilowatt? We
Huh.
convert.
But then we want the answer in horsepower. And from horsepower to watt, we multiply with horsepower is a bigger unit. Okay, so 1 horsepower is 746 watt. So from watt to horsepower, we divide by 746. So this many horsepower. Two,
Divided.
yeah, we divide it. See, 1 horsepower is 746 watt. Okay, so from watt, if you're converting it to horsepower, you're dividing by 746. So that is 3.97.
A weightlifter lifted a load of 200 kgf to a height of 2.5 m in 5 seconds.
Okay, so they have given us, like, let's write the information which is given. So they have given us load to be lifted. I think they have given us weight of the object, right? Weight is how much?
Uh,
200.
200 into 10
Why are we
because we
multiplying
are converting it. We are
from
converting it. That's why.
where, which unit to
So
which
it will
unit?
be kgf to Newton. So it will be 2000 Newton.
Okay, fine. Then
Distance is s, which is 2.5.
the distance traveled is the height, which is 2.5. Okay,
And time is 5 seconds.
time is 5 seconds. Okay,
Work done is W is equal to F into S,
okay.
which will be equal to 2000 into 2.5.
But where is F?
2000 is the F.
But so that weight which you're lifting is equal to the force which you're applying to lift the weight. Okay, let's see. Let's see the fire. So work done is force into displacement. So this is,
Uh, 2000 into 2.5.
okay, that is
Uh, I think 5,
1000.
5000
What is the unit?
joule.
Joule.
And power developed will be W by T, which is 5000 by 5, which is 1000 W, which is equal to 1000 W.
What is full form for W?
Watt, 1000 watt.
Again, the same type of question. There is no difference. A machine raises a load of 7 Newton through a height of 16 meter in 5 seconds. Kushi, you know how to do this question?
Do we use the formula W is equal to F into S?
Okay.
Yeah, so the value of W is 750.
No. F is
Sorry,
750.
F is 750 and
Uh-huh.
S is 16 meters.
Okay.
Yeah, I'll just multiply and I'll just 1 second. Yeah, it is 12,000 Newton meter minus 1.
12,000. Okay.
Yeah.
So this is for the first part, energy spent by the machine. Second part, power of the machine.
So the formula for power is work done divided by time.
Okay.
Um, so work is 12,000 divided by time, which is 5 seconds. 24,000.
2400.
Sorry, I'm multiple. Sorry.
So 2400 is the answer. Watt. Okay. So So as I said here, if since in this question it's 100% efficient, we leave the answer as 2400 watt. But if suppose if it was given in the question that it is 60% efficient, then in that case this is not the correct answer. Like after finding this, for the final, the actual power is 60% of 2400, or just 2400. Okay. So if efficiency is mentioned 60%, 50%, 40%, 75%, just calculate that much percent of the power which you calculated. Okay, so this 0000 cancel. 240 into 6, so 1440 watt. This is only applicable if it is given, suppose in the question, that it is 60% efficient. For 100% efficiency, you just leave the answer as it is, like work by time. That's your final answer.